Welcome everyone. I'm really excited to show you today a lot of cool things around data modeling and data import. My name is Michael Hanger. I've been with Neo4j for more than 8 years now, which has been a really long time, but it's really been cool all the time. I've been working in a lot of places, lots of Spring Data Neo4j, data integration. I started the Epoch library and have now a lot of contributors there. Also working on GraphQL, graph algorithms, and other things as well. If you want to reach me, best send the email to dev@neo4j.com, then our team will be able to answer you. And you can also follow me on Twitter to get latest updates on all these topics at Neo4j. Okay, today we want to look at the Yelp dataset. You might have seen it before, used with Neo4j. I really like this dataset because it's large enough to be interesting and also complex enough to be interesting, but it's also not gigantic, so we don't wait like hours for import. We want to start by looking at how to model this data, and then dive directly into importing data with different ways. So we look at load CSV, how to use Epoch for importing the data, fast bulk importer, and the new Neo4j ETL tool that I want to demo to you today. Talk a little bit about graph refactoring, and then also look at what we can do with this data. So it's a lot to cover. Because some of the imports take a little bit longer, I will only talk about them and not let you wait for 5 or 10 minutes for them to finish. So please bear with me on that. And if you have questions, as Angelica said, please put them into the question box. And if we are not able to answer them, then we can still send you an update in the follow-up email. Okay, the data is the Yelp dataset challenge. You have probably seen that before with Neo4j, and Yelp yearly publishes a large dataset that they make available to scientific competitions, and it has quite a lot of reviews, 170,000 businesses, 11 million reviews, and 11 metropolitan areas, and about 1 million users available. And you can download it yourself. Unfortunately, we can't share the data because you have to click through the Yelp terms and conditions, but you can just go to download dataset, put in your details, and then you can get the information. And there's also documentation on the dataset, so all the data is available as streaming JSON, so where there's one element per line. So there's data for businesses, business ID, name, neighborhood, and so on. Also geo information like latitude, longitude, and also categories linked as an array here. And then there are the reviews. So we have the review ID, the user who did the review, the business which was reviewed, stars, when the review was issued, and the text for the review. And then some votes on that. And the user themselves has, of course, their name, how many reviews did they do, since when have they been yapping, an area of friends, which can grow pretty large, actually, and then a bunch of additional votes. There's also check-ins and tips, which are not covered today, but the other things should give us enough for a data model. If we look at data modeling, basically, the first question is, do I need a graph database for my data? Whenever I have complex connected data that has a lot of like varying data, a lot of interesting connections, and if I want to answer complex questions that would usually involve a lot of joins and variable numbers of joins, for instance, you have like trees or long paths or something like that, or you don't know how far you have to join. Also, if you have self-joins like social networks and things like that, or categories, or if you want to do path searches like geoinformation or network management or dependency management, then graph databases are quite cool. The basic data model that Neo4j and other graph databases support is the labeled property graph, where each entity is represented as a node, which usually would be like a noun. Attributes on the nodes can be anything, so basically key value pairs of attributes. And then these nodes are connected by relationships, which oftentimes represent verbs. So for instance, I reviewed a business, or I wrote a review, or I am I'm friend of someone. And then you can also put attributes on the relationships as well. basically, here's an example of a few people having a relationship. So Dan loves Anne, and Anne loves Dan back, which is nice. And then they both have a car, and then you, for instance, see that on this trust relationship, there's also additional attributes. So we have nodes, relationships, the properties on both, and then also additional labels on nodes as well. And as I said, nodes are most often representing things in your domain, so entities or concepts. You structure your domain with relationships, from trees to networks to semantic relationships. And then you can put properties on both for attributes, for metadata, data that you might want to just store and show but not query on. So for instance, if you have just a blob of text or something like that you don't really want to query on, but you still want to retrieve. And in terms of properties, we have strings, numbers, booleans, and since Neo4j 3.4, date, time, and spatial as well as attributes, and arrays of these. So that's kind of what you can usually store on nodes and relationships. I also linked the manual pages here, so in case you want to look at the slides later. If you look at our model, we usually say, okay, when I just discuss a domain, I take a whiteboard, or I take a tool like this arrows tool that a colleague of mine wrote that just allows you to add let me change the style here to the large one. To add nodes, so for instance, I can say I have a user, and the user has an ID, which is a string. It has a name, which is a string, and it might have like reviews, which is an int. And then I can say, okay, this user then wrote a review, and this review has, for instance, a date and stars and text. And this review reviews a business, so I can say, okay, then we have our business node. So this user wrote this review, and then here we have our business node, which has also an ID and name, and also something like latitude and longitude, which are location or geocoordinate. And opening hours, and so on. And so I can basically take our domain description, or we can even look at like the documentation here from our domain, and kind of move the attributes that are interesting to us into either nodes or relationships, basically. So we can also have like a user friendship, or a business is in a category. Then we can model this as well. And so, for instance, I can here take this as a category with a name. So you've seen that here in the data, actually the category is an array here, but for our use in the graph, it makes more sense to pull out categories as a node, especially as you then can easily query across these categories, or you can even group them together into higher level categories and so on. You can, for instance, do a similarity of businesses or even users based on categories. And so that would become our data model here. This tool is also quite cool because it can export these things into SVGs or even Cypher, so you can even generate Cypher from that. So that's quite a nice tool, it's arrows tool. Okay. Basically, what you do in graph modeling, you start with some basic entities and their relationships to answer the first questions, and then if you have more requirements or more questions, then you add to this domain. Or if you get new data sets that you want to join to the existing data set, then you can just continue to add relationships and nodes to your domain. There are some things that you should consider. For instance, depending on what you want to ask for, the question is, should I model, for instance, something like a review as a relationship, if only the fact is interesting that a user reviewed a business, or should I extract this into a node where a review is really an entity or concept in my domain that is also connected to other things, or that you want to treat as a first-level citizen in the in your domain, and then you would turn it rather into a node. And there are some more questions like that. What do I store as a property? How do I structure relationships, and so on. So there's a lot of kind of things to consider for modeling to have a good domain, but also graph models are not static. You can always add to them, you can refactor them. I'll show an example later on. So that's quite easy to do. If you want to see more data modeling things, you can look at Neo4j GraphGIS, which are graph examples from lots of different domains. You can check out Neo4j Sandbox for some other graph models, for instance, for network management or recommendations. And there are also regular data modeling trainings. The next one is in New York for Graph Connect. So if you're perhaps coming to Graph Connect and you're interested in data modeling, then there's also a training for you. Really quick on Neo4j query language Cypher. I just put it into the slides here to recap that. So basically, you draw in Cypher using ASCII art graph patterns. So you have parentheses around nodes and then arrows for relationships, and you match these patterns against the graph. You can use key value syntax here, or just where conditions with predicates, and then you can also do aggregations, and after aggregations you can also do other things, and then of course return your data. For updates, we have loading data from CSV, which we'll look into later on. We have both create, which is just an unconditional creation, updating of properties. Merge is an upsert or get or create, so match or create operation. So if the thing is already there, then it will just be returned, otherwise it will be created. Which has some conditional clauses as well, and we can also use merge for relationships, and then we can also remove properties and labels, and also add new labels on top of that. Procedure calls, because we're going to use some procedures really quick as well. So you call them with the call syntax, and then the procedure name, pass any parameters, and then you yield the columns that you want to return or work with. So even if a procedure returns like 10 columns, you only need 2, then you just yield the 2 columns that you're interested in. And then you can do any other kind of cipher that you want to do. You can also call procedures standalone, that's also possible. And then you can also use user-defined functions, just like any other function in any other expression, for instance. And last but not least, indexes and constraints. So you can create indexes on properties of labels that are used for quicker lookup, or constraints, for instance, for uniqueness or for existence of properties on nodes and relationships. Okay, for preparing our data, we first should look at data quality. When I prepared this webinar, I ran again into data quality issues as usual. Biggest things is like text with stray quotes, or things like smileys that add in backslashes, which then escape the next quote that comes at the end of the text, or something like a 15-inch monitor, which also comes with its own quote. So you have to really be careful, especially in CSV, that you get your escaping and quoting of quotes and new lines and multi-line things right. So it's better to check your data up front and make sure it's clean to save you some troubles later on. You also should determine which attributes are text, which are numbers, which are booleans, which are geocoded, which are dates, and so on. Especially if you have something like a text format like CSV, or if you have JSON, and then you have to determine, oh, this is actually a date and not just a string. And basically make sure that you sort this out before. That saves you a lot of things. Something else for data preparation, which is quite important, is to create the proper indexes and constraints up front, which allow you faster lookups. So basically for match and merge operations, Neo4j, if possible, uses indexes for the key properties. And if you don't have an index or constraint, then it does a full scan over the whole label, which gets continuously slower as more data is in the database, versus if you have an index or constraint, then it uses just a fast index operation for getting this information. Graph databases actually use indexes only to find starting points, unlike relation databases and other databases, which also use them during join operations. But as soon as we have our starting points, we then just follow the graph relationships, the pointer in the graph, basically, to go from A to B to C. So that's kind of the index in Neo4j is really just a lookup index for starting points, nothing else. Okay, here would be our constraints. So what we can do, we can just take them and use them. Let me just copy them out into my Neo4j instance. So basically, I set up Neo4j desktop with a graph, empty graph, Neo4j 345. I created this graph. I also installed in the plugins setting the epoch procedures and added a setting here that says it is allowed to import files, just as a quick starter. And then I basically started the empty database. And now we can open the Neo4j browser to interact with our database. We can also, if we want to, use Neo4j shell, Cypher shell. So if we start Cypher shell here, then we should be able to connect to the instance as well. So we can give our username and password, and then we can also operate here within the shell or pipe things to the shell as well. Okay, cool. Neo4j browser is here, and since the last versions of Neo4j browser, there's an optional multi-line editor statement editor here. So we can basically just take our constraints here and pass them into this input box, and then it basically will execute them one by one, and you see the results. So this can also execute other statements. So this still has a few small issues. That's why it's optional, and you can enable and disable this multi-statement query editor as you need it. Okay, now we have our indexes and constraints. So we basically have a constraint on each ID. So user ID, business ID, review ID, category ID. And for business, we have location and city and the review date as well. So for quick lookups. So how are we going to import the data? I downloaded the Yelp data set as JSON. So you can see here, for instance, as the review JSON, and you saw the same things on the Yelp website. So it's streaming JSON, so it's one element per row. And if we let's see, for instance, if you look at how many businesses do we have in the JSON, it's 144,000 businesses in our JSON. So, and as I want to start with CSV import, with load CSV, I need to convert this JSON into CSV. So either I can use something like Python and go over the JSON and generate the CSV, or we can use the very handy tool JQ, which is a very powerful JSON tool that can do anything that you can imagine to do with JSON. So for instance, here I just access a bunch of the properties, so business ID, name, latitude, longitude, stars, review count, address, city, and state. And I also turn this category array into a semicolon separated list. And then I turn it into a CSV. And then I get this business CSV out of this. So, and I do this for all the files that I have here. And if I run my script, I put them just into a script here. Then it takes all the JSON and turns it into CSV. So, and then basically I have here in my CSV directory, I have, let's see. We just have our CSV files. Let's see if that works. Voice access too slow. So, and basically the JSON and the CSV that comes out of this looks like this. So we just have for our review review ID, user ID, business ID, stars, date, and text, and that's kind of the CSV that we got out. What we then want to do is we want to copy these CSV files into the input directory for your Neo4j instance. So if you go here to your Neo4j instance in Neo4j desktop, you can just open the import folder, and then you see I already copied these CSV files into this import folder, and then we can get started. Please note that CSV is of course all about strings, and so we have to convert data types ourselves, for instance, to integers or to floats or to booleans, or we can turn it into a date or date time. We can turn it into a geospatial point, or we can, for instance, take something like the categories and split them by semicolon to turn them into a list of strings. So that's all things that we can do and will do. And basically, the simplest approach is to just take reviews.csv, and then for each row say, okay, we merge a business, so we get or create a business, and we merge a user. So that means if the business already exists, we just use it. If it's new, then it creates it by business ID, by user ID, and then we do the same for the review. And then we just set the attributes on review that we have in this CSV file. And then we create relationships between a review and business and user and review, basically. And that would be it. And so which is quite compelling and quite nice to do. So we can basically just take this and run this in our Neo4j browser. So, and then it would just go over this and load the data. Let's see. It's probably the go-to meeting software that slows this down a little bit. Come on. So if you want to see what it's doing under the hood, we can just run and explain here on top of this, and then we see a query plan that shows us what it does, basically. So it looks at does the load CSV, and then let's see, can I just go? Does the load CSV, and then does merges all over the place, and then turn this data into the graph. So let's see, this is still running. I don't know why it's still running. It should be much faster because the CSV is actually not that large. Because if you look at CSV, review.csv, it's only 400,000 lines. With a lot of new lines from the text, probably as well. So I think I used smaller files yesterday. Let's see. Let me just support this and use the small files that I generated here. So we just replace them and run this again. Oops. Something happened to my instance. Probably. All right, there were some text issues. What happened here? Okay, I'm restarting the instance and let's continue. I'll check this out later. Basically, so this is kind of the naive approach where we load everything from one file, which has to create each entity multiple times, basically, or check for each entity multiple times. So it's often better to turn this into multipaths where we load each element individually. So we load the users from user C3, the businesses from businesses. We can also set all the properties and turn them into the appropriate data types. And then we can also run the reviews by only matching the business and user and not merging them, and then directly creating the reviews from here. And we can run this either with the multi-line editor in the Neo4j browser, or we can just pass this import file to Cypher Shell to run at once. So let's try this again. If the non-naive approach looks better, so it restarted my server, and we can just basically import. So we can just use the multi-statement editor here. So we have like our 3 statements and the constraints again. And if you run this, hopefully this time it's going better. And then it loads the data from these files. So as you can see, it used to work. It's probably just my little computer's overlooked. Something else that could happen as well is because Neo4j is a transactional database, that the transaction state in memory grows too big, and you actually want to periodically commit your data to the database. So for instance, if you really are pulling in like all reviews and all users and all businesses, then it makes sense to commit in batches with using periodic commit to have smaller operations in memory. Okay, let's see. Oh, that's done now. So we now have like this data in our database, and we can look at the nodes and relationships here. Right. So, okay, cool. That's kind of the load CSV. The next way of importing data is using APOC and the JSON from Yelp directly. APOC is an utility library for Neo4j with a lot of user-defined procedures and functions. In total, we have more than 450 procedures and functions for lots of different areas. Today, I only want to look at some of the data import ones. And as I showed you before, you can just install APOC by opening your database and then clicking install APOC here, and then you get it installed in Neo4j desktop. We want to look at APOC load JSON today, which is a procedure which takes an URL or file and then turns this URL or file into either a single value for JSON documents, or in our case where we have streaming JSON, it returns 1 row per streaming object. So, and if we want to run this, we can just take the data that we have directly from Yelp and look at it. So we can, for instance, take the user.json and return the first 10 users. So it just takes the JSON file and returns the first 10 users, and you see that it has user with its attributes. So the friend area is really large, as I mentioned before. So some of these users have thousands of friends in their array. So that's something to be aware of. So we can also then just take this and see how many entries are in this file by just returning the total count, and it should be like something around 1 million users here. So while it's computing that, let me clean out the database so that we can look at the import again with APOC. And with APOC, it's quite similar to the load CSV, only that we don't have to change data types like floating point and integer values, or we don't have to do booleans and so on. Of course, JSON already has the right data types. And here we can, for instance, take 1,000 users and load them into the, or 10,000 users and load them into the database. So I'm not really sure what's happening with my disk today, but something seems to be a little bit off in terms of computer performance. So we can just, as I said, take a bunch of users from our JSON and then run this here. So just import this here, and then it loads 10,000 users into our graph. So in 6 seconds, and I actually stored some of the load scripts here. So we can also load some friends. So the friend loading is basically we take the user, take the friends array from the user, turn that into rows again. So we find the user, and then we just get or create the friend, which might not be there yet, and create a friend relationship. You might see that I left off the arrow tip here. That's because if there's already a friend relationship in one direction, I don't want to create another one in the other direction. And something I mentioned before is that these friends are quite a lot. So you see, I only take 100 users here, but it still created 21,000 relationships. So these 100 users have about 200 friends, obviously, on average. So you shouldn't underestimate, if you create these kind of social networks or other purchase histories also, that you want to make sure that your batch size is small enough to not accidentally blow it up by having then too many elements per user. Okay, we can also load our businesses here from the JSON. What I did here is I just merge a business, and then here I use a map projection that selects a subset of attributes from the JSON, so the name, review count, and so on. So all the attributes that I don't need to change into a map, and then I can just add these attributes with plus equals to our business. And I only did a special thing for the location where I turn the latitude, longitude into a map and then into a point value, so it's in geospatial. And then for each of the businesses, we also take the category similar to the friends that we just did and create the categories. So for 10,000 businesses, let's run this. So as I said, I don't want to import all of them because then you have to wait for too long. And while that's running, we can also look at the reviews. So we take 100,000 reviews. So to actually find some businesses and users that we already imported, and then just find the business and user for this review, and then create the review, set the text state stars and so on, and then connect the review to the businesses and the users. So now we have our businesses here, and now we can create our reviews. So, and then basically I get the same data structure as I had before with load CSV. Okay, yeah. So watch out for the cardinality increases when loading friends or categories. And the thing that we currently saw is that this is only single-threaded, so it only uses single thread to load the data, and the transaction state must fit into memory, as I said before, with periodic commit. What can we do to do this better? We can use another user-defined procedure called epoch periodic iterate, which basically takes a stream of data and splits this into batches and runs these batches independent of each other, independent transactions, and optionally in parallel as well. So here's an example. So we can take 200,000 users, for instance, which would probably otherwise not fit into a single transaction, and load this as the first statement to periodic iterate. So this is kind of our data source or driving statement. So we return like one value per row here. And then these 200,000 values are batched into batches of 10,000. And this second statement is then executed for each batch as an aggregation in parallel with 4 cores and 10,000 batches. So let's try that. And what we should be able to see is that it, first of all, should use all CPUs, but my CPUs already seem to be quite busy. I think that's because of the GoToWebinar. And yeah, and we can then load these users, and we can actually see how the users are being added. But actually, first I wanted to finish the review, adding these reviews. So let's finish that, and then while we are continuing, I'll come back to the periodic iterate later to show you how it's run. We can do the same with other data sources. So we can also use load CSV as input statement for our periodic iterate, but we can also use it for instance, graph refactorings, or if you pull data from a relation database or from MongoDB or from somewhere else, or if you just want to modify data in the graph or so, then we can always use this kind of split between one statement that drives the data import and the other that actually does the actual modification or change. And then we can play around with these batch sizes in parallel, yes, no, and so on. Actually, I took a few notes here. So batch size is usually good to have between 10 and 50,000. Iterate list is always better because it doesn't actually execute a second statement as is, but it turns this batch into an unwind. So it turns this into a single statement and doesn't execute 50,000 statements basically for the batch, but a single statement that takes this list and turns this into an unwind. And as I mentioned before, everything can be a data source. For parallel execution, you should be careful. For instance, if you create relationships, then it might be that you have conflicting nodes, and so you have to be quite careful there. Usually, I don't use parallel for creating relationships, but there's a retry option that it also tries to rerun failed executions. You can control the concurrency and watch out that the memory usage is number of threads times batch size. So if you have 10 threads, with 50,000 each, then it's 500,000 records that are created concurrently at the same time, so that your memory should be enough for that. Next thing we want to look at is the Neo4j import tool, which is basically a command line tool that allows us to skip the transaction layer in Neo4j and import initial data sets into your database. So it looks like this. Neo4j admin import has a lot of options. Basically, mode CSV is important, and then providing data for nodes and relationships, and then all these other options are for data quality control and special configuration for other quotes or delimiters or something like that. And so basically what we saw before so far in Cypher was that we always went from the data using the transactional database to the Neo4j store, and the import tool basically skips this transactional phase and writes directly from raw data to store files concurrently over all the CPUs, and can import terabytes of data into your graph. The CSV file structure is a bit custom, especially headers, because it uses that to kind of determine the structure of the graph. So if you have a graph like this, I have a user with some properties who wrote a review with an ID and text and stars, then our CSV would look like this. We have one file for the users where we have the ID, which you also mark as an ID field for the user, and name property for the review. We also have the ID and text and stars. We actually could put in here that stars is an int. And then for the relationships, we have a start ID. We say, okay, this ID comes from the user, and this ID comes from the review. And then we could also add additional properties for the relationship here in this table. And that's kind of the format, especially header format, that you need to generate to kind of encode the graph structure in these headers. And we can generate these files either we just dump the data out of the original database, we get it from somewhere, like many open data sets are available as these. We can convert it from JSON with JQ or with Python. What's important is to have these headers, so you can either write them by hand, which is not too much effort, or you can also generate them. What's quite useful is to generate them as single line files and then use them as the first file in the list of CSV files to parse, so you don't have to kind of edit headers at files that have gigabytes or terabytes of data, because most text editors just die on such large files. So it's better to separate out the headers. There's also a cool trick that you can actually use different headers for the same file. So you can also choose to ignore certain columns. So you can also use the same file multiple times as input file, and then just use different headers for the same file to kind of import parts of the structure, especially from denormalized data. That's quite useful. And then we use it basically by passing in our business category user and review nodes, each with a header and a actual CSV, and then the relationships category friends, wrote, and reviews, again with a header file and a CSV file. We say we don't want to care about missing nodes because especially friends are only partially correct, and of course multi-line fields because review texts have many new lines in them. And then when we run this, we get some fancy output for the input tool. And then depending on the data volume, so this is 60 million relationships, 7 million nodes, and 24 million properties in 11 minutes. Depends, of course, on the number of CPUs and memory available and the disk performance on your machine. But that's quite useful for initial inputs of large data sets. Okay. Something to note is that we have to create indexes constraints afterwards. So after the input tool ran, we have to open Neo4j browser, Neo4j Cypher shell, and open it. We can import like billions of records with the input tool. You should have enough memory and disk available, especially for the graph store that it creates. And what's cool is that the CSV can be gzipped. And you can also have multiple CSV files and then even use regex patterns to put them into the command line, so you don't have a too long command line. But you can also read all these command line options from the file, which makes it also better to use, for instance, on Windows, which has limits on command line length. And then you have as you saw already, special formatting for data types, for instance, int, boolean, arrays, date, and spatial. For spatial, you also have to format the data into a map-like structure to turn this in. Okay, let's see how far our browser got with importing the data. It doesn't like me today, so it's poor Mac is just overloaded. Okay, so unfortunately I can't show you or actually let's try this. So I can stop this and just see if this is better, and then and then we can run the periodic iterate here. So, but what I actually want to show you is the Neo4j input tool, the ETL tool. So this is a tool that we wrote to make import from relational databases easier, meaning you can initially import your graph from the relational database as is, so basically a one-to-one import. It works quite well if the entity relationship model is still normalized, so it's not like already denormalized for performance reasons. And you still don't want to forgo the graph modeling, otherwise you get just perhaps a bad relational model into your graph, and then you get like substandard performance for querying. So still do your graph modeling, because you can still take the data and then refactor your graph afterwards into your graph model that you want to do. Or it's really good as a first step of getting data in. The Neo4j ETL tool has a few transformation rules. Basically, if you have a normalized entity relation model, it's quite easy to turn it into a graph. So all entity tables will become nodes. Foreign keys, one-to-one, one-to-n will become relationships, and self-joins will also become relationships, and join tables or link tables will also become relationships. So there's a rule: whenever a table has two foreign keys, then it will become a relationship, which we'll see in action in a few minutes. And then what you could also do is remove artificial keys. So that's something that the ETL tool does not do yet. And then afterwards, you can refactor your graph. So there's also these transformation rules are also explained in more detail on the developed pages. The ETL tool itself comes as a Neo4j desktop app, but there's also a command line version that you find on GitHub. And it supports all relational databases that have a JDBC driver, which is quite cool. You can also provide your own JDBC driver for the databases that are not packaged. So for MySQL and Postgres, the JDBC driver is already bundled in the tool. For all the other databases, you can provide your own JDBC driver. And as I said before, it currently does only a simple one-to-one mapping, but it has different modes of importing the data, which you'll see in a second. So let's have a look what it looks like. Let me just close this browser and stop this database. Basically, what you can do is you can ask us for a for an activation key for the ETL tool, and then you can add your activation key here. So you see I have Neo4j ETL added here, and then you get basically here a new graph app. That's what these applications are called. New graph app called Neo4j ETL, which you can just sort. Let me just close this, which you can just sort. Then you select which project you want to run in, and then you're ready to go. And basically what you do is you provide the data for your relational database. So in this case, I would say Yelp 2 because I already got one. Database is Yelp. Don't need a schema. The user is Postgres. Password, and then I can test and save this connection. And then I have a Docker image running with the Yelp data as Postgres database. So you see here we have the user data, user table, business category table, review table, and user friends table. And then each of these tables is, as you would expect, just a relational table, all with primary keys and foreign keys. And when I have this configured, then I can say, okay, I want to input my data now. I can select my relational database connection. Oh, by the way, if you want to use different databases, then you can also use others. And then you might be able to provide your own JDBC driver depending on the database. So if I want to import my data, I select my database and the Neo4j database that it is meant to go into. Then I say start mapping, and then it extracts the database metadata from the relational database. And when this mapping is successful, then I can look at this. So here we have our category, business, user friends. And so I, for instance, can say this business category is meant to be in category, and user friends is just friends, for instance. And so we can also edit, for instance, attributes of the entity. So for instance, if I want to turn business ID into ID only, or things like that, then I can do this here. And Then when I'm done editing this, I can save this mapping. And when I've done this, I can select which way to import the data. And here Neo4j import is the bulk import tool, which is most suited to these kind of larger databases. And if I run this, which I won't do now, then the following happens. Basically, it takes the tables from the relational database, exports them into a CSV, into the import directory, and then you can import these via either the bulk importer or via load CSV with Cypher Shell or direct board connection. And when it did this, so it takes about 300 seconds to export the data from the relational database. And if you look at it, it created about 5 gigabytes of CSV data on disk here. So that's kind of the size of data that it has in here. So for instance, 500 megabytes for user friends connection. And then it runs the import and it says import successful. And then we have the data in our database. So we can then take our database and start this database. Let's do this here. And something you might have noticed is that it actually doesn't turn the review into a node, because it actually falls under this rule that it has exactly 2 foreign keys. And so it turns it into a relationship, which is a little bit unfortunate. So there's something that we still have to add to the tool to configure things like these rules. But this enables me to show you some graph refactoring. So for instance, if you say, okay, we have a review issue. So review was imported as a relationship and in the wrong direction. So if you look at this, it actually draws the review from business to user, which is also not the direction that we want to have. So we have to do 2 things. We have to invert the relationship and extract the node from this relationship. And because it's a lot of data, we have to batch these updates as well. Okay, and fortunately in APOC there are procedures that can help us with this. So what do? We find our user reviewed a business, and then we reverse the relationship with APOC refactor and invert. And then we take this relationship that was reversed and extract this into a node with the label review, with the relationship type reviews and wrote on either side, and then we get our data. So let's do this for a small number of relationships, just to show you that it's looking. Open the browser, and come on. And you see, or we should see, that we have our data in the database. So we have our business categories and users, and you see that there's this review relationship here, right? So we have kind of bunch of these review relationships. Come on. So, right? So which hold all our data, so review date and text and all the other things, right? So if I run our statement here, we basically can get the reviewed relationship, invert it, and then run extract node, and then return the user, the business, and the review node. And if we have Neo4j browser configured to connect the result nodes, it also should show us the graph. So let's see what this looks like. Oops, I think I forgot to install APOC here. Let's do this quickly. So it installs APOC and restarts the database, and then we can try again. There we are. So let's run this again, and now it should be able to find our relationships. Review. Sorry, I renamed it in the editing. So, and now we see it turned from these relationships into a user wrote a review. Can, for instance, configure here the date to be caption. User wrote a review to this company. So now if we want to run this as a larger scale refactoring, we would wrap it in apoperiodic iterates, and we get our businesses here, and then run this for a larger scale. So we can do it, for instance, for 100,000. For 100,000 business reviews. And while this is running, you can continue here. So other refactoring steps we can do is we can remove external properties that were added, can change data types, for instance, the spatial and daytime data types. We can merge duplicate nodes, so in case some nodes were created as duplicates, we can merge them, or we can also merge duplicate relationships in case we want to do this. Okay, and the last way of importing the data is using a driver. So either one of the official drivers or one of the community drivers for Neo4j. And basically what you do is you take the data, for instance, from the JSON, and then just execute Cipher statement with this data as an input. So in this case, you read one record from the JSON at a time, and then execute one Cipher statement at a time to create this business as parameters, because we passed in the business item here from JSON as parameter. So that's something that we can do in any language, so in Java, in .NET, in JavaScript, or in Python. And if we want to, we can also batch this. So for instance, we can create batches of a list of 1,000 items, and then use unwind to unwind this list into rows again, and then do 1,000 items at a time. I also wrote a blog post about this, so in case you want to have a look at this efficient data import, then check this out. There are other tools as well. So for instance, we can use Pentao, Pentao Kettle. There are some Neo4j steps, different Neo4j steps. There is Tableau, talent integration. Stream sets can be used with the Neo4j JDBC driver. And there's a tool from our friends from Graphware called DataBridge that can be used. And some other partners also have Neo4j import tools as well. And now that we have our data in a graph, we can do a different kind of queries. We can, for instance, say, okay, I want to find, for instance, the average reviews for businesses, and then get the top 25 businesses from that. We can do something like similar categories to a category. So by having kind of joined businesses in between. So you would see, okay, similar categories to dinner theater are restaurants, nightlife, arts and entertainment, and so on. So you have these kind of joint categories. And so you can also, of course, compute similarity between businesses or between users or between neighborhoods and things like that. So all these kind of things that you want to use in a recommendation. You can run graph algorithms on this data set. So for instance, you can say, okay, I want to find if I have businesses that have concurrent reviews between them. So a business has been reviewed by the same user. I want to use this business-to-business graph, actually this projected business-to-business graph, to compute a PageRank score for businesses. So we see, for instance, certain businesses that have a high relevance in this concurrence graph. And then, of course, you can also use this data set to build applications. So my colleague Will did a space-time demo that allows you to filter for geolocation and for data ranges, and then you get statistic charts. Besides the graph the map visualization, you can also get charts about ratings and categories and so on. So you can check this out. It's on GitHub, and you can run this here in Light. So let's see if it finished our refactoring. Now it did 10,000 updates in 120 seconds. And it didn't have any failures, so it was successful. And now we should have quite a number of reviews in our database. So let's see, it should be 10,010, 100,010. Yeah. Okay, cool. And so I could just run this over the whole database if I remove this limit here, and then I can refactor my whole database basically as well afterwards. Okay, and with that, I want to close. So it was quite a lot of things, and my computer is not in use anymore. That's why it was a little bit slow. So Angelica, I don't know if you have time for questions, but otherwise also feel free to reach out to me on Twitter or on Slack and or via email. Otherwise.